Last few problems. Number 8, it's pretty easy. Here, I'm not given the function, so I don't have any expression for this, which I think might trip you up from watching the in-class assignment today. But I'm asked to calculate the limit as x converges to 2, and I'm given the fact that f of x is squeezed in between these two formulas. That's what this says. You can think of it that way. Now, we use something called the squeeze theorem, which says that I can just take the limit all the way across on this inequality. It turns out that if I just plug in x equals 2, because I'm taking the limit as x goes to 2 into this left side and into this right side, it turns out that the limit of the inside is actually between the limit of these two pieces at x equals 2, which I can just plug in the number because there's no weird thing with denominators in it like we had in number 7. So no problem here. I can just plug in x equals 2, and I get that on the left side, I've got it bounded below by 2, but on the right side, I've got it bounded above by 2. The only y value that's possible in the middle of these two is 2 itself. So therefore, the limit is actually equal to 2. And that's the squeeze theorem. Pretty simple. This one is a not exist, and I wanted to show you this because this is something that trips up a lot of students. My daughter just learned absolute value, and she told me absolute value takes numbers and makes them positive. Yes, it does. But if I have a variable in there, it's not actually, I have to think a little bit because that variable, it could be positive or negative. If it's positive, then it's just itself. But if it's negative, it's positive really, right? So I need to change the sign. Before I start, I did my trick I showed you before. I just ran it on Excel, and I'm looking at x goes to -6. So I wanted to show you what I see. I'm going to start from -7 and then scroll down to -6. I just put the formula in just like I did for number 7. And what I see is that the limit doesn't exist because you see this jump right here at 6? It jumps right at 6. On the left side of 6, the y values are getting close to -7, but on the right side of 6, they're getting close to a completely different number, +7. So we say that limit does not exist because it's not one thing. It has to be one thing to exist. How do I see this algebraically? Well, I have to write it as what we call a piecewise function. X plus 6 in absolute value is, if x plus 6 is positive, it's just itself. If x plus 6 is a negative number, if I put a negative in front of it, it'll make it positive. So this is how I write the negative side number if x plus 6 is less than 0. So it's two pieces. So this is how we write it. It's very strange, and I do think people should teach this from day one, so all things with absolute value can be done cleanly. The first case is this top case, or this bottom case. What if x is less than -6? X plus 6 being less than 0 is the same thing as x being less than -6. So what if I'm in this bottom branch here? Well, in the bottom branch here, the absolute value of x plus 6 is really minus x plus 6. I got that from the underlined part up at top. But then these two things cancel, right? And I'm left with a -1 below. I don't know why I'm saying right. I'm sitting here in my car and I'm not talking to anybody, but pretend I'm talking to you. I get -7. And I got that on the Excel spreadsheet. If you recall, I got -7 if I'm to the left of 6. On the other hand, so the limit is -7 if I approach x from the left, -6 from the left. Case 2 is, what if I start in this top branch right here? If x is bigger than 6. Well, if x is bigger than 6, then I have that x plus 6 in absolute value is just x plus 6. They cancel, and I get 7. Exactly like I saw from the Excel spreadsheet, I get 7 if I'm approaching from the right of 6. So as x approaches -6 from the right, the limit is 7. These two things don't match. In order for a limit to exist, these two things have to match, and they do not. So therefore, the limit does not exist. This is the last problem. We did it in class. I'm introducing a lot of ideas all at once. So this is another piecewise defined function. I mentioned in class that we talk about some things that happening differently at some times than other times. For example, when someone is starving, we know that they lose a lot of water in the first few days, but after the first few days, then they start to stabilize, and it's really energy that they're losing. So there's kind of two different functions that you have to describe weight loss. There's the fast phase that includes the water loss, and there's a different phase that includes a slower loss. And so you can think of this this is a fake example. I just gave you a real example, but you can say, if I'm below 3 days of starvation, do this. This is what I'm going to see. If I'm above 3 days of starvation, this is what I'm going to see. So that's when you have these piecewise defined functions. What you don't want to see, though, is if I'm describing body weight, I shouldn't see a jump in body weight right at 3 days. If I have one description before 3 days and a different description after 3 days, your body weight won't be suddenly, 70 pounds and then 50 pounds. It will go down gradually to the 50 pounds. When it doesn't jump like that, we call that a continuous function. So I just plugged in a value. What they want here is they want to know the value of C that makes this function continuous. It doesn't have that jump. I plotted just with C equals 2. I used the guessed and test method. I just tried a number, and it doesn't work. I see that C equals 2 makes it jump. This line shouldn't be here. That line will appear on your calculators too. This is called a jump. It puts the line there because it's just connecting dots. It's actually a gap. So this is the left side of the curve, and this is the right side of the curve, and they don't hook up. What I'd like to do, or what the problem wants you to do, is to find the value of C that doesn't make it jump. I know to the left of 2 and to the right of 2, everything is fine. It's a nice smooth curve, as I saw before. To the left of 2, it's nice and smooth. To the right of 2, it's nice and smooth. It's right at 2 that you have a problem. So I have to find the C that makes them hook up. Well, how do I make them hook up? I would need to take this Y value and scoot it up so they match. I need the Y values to match at x equals 2. So I plug in 2 to the left portion, and I plug in 2 to the right portion. The left portion's this, the right portion's this, and I want them to hook up and match right at x equals 2. So I get the most simple kind of equations, the linear equations, and I can solve for C, and C ends up being a third. This is the second time I'm doing this problem because I made an arithmetic mistake. The first time I did this, I accidentally subtracted 2C from both sides, and I got the wrong answer, but I tested it and found out. This time I got the right answer. I plugged in C equals 1/3 and I graphed, and I got a perfect smooth curve. It does looks a little funky and weird at 2, but it's definitely smooth and hooked up. So that's what I wanted. When I had the wrong answer, it still had that line in there, so I knew something was wrong. So I hope this explains clearly how to finish your Webassign. I hope that your quiz goes well. I'll probably be giving you a Friday vodcast just to tell you a little bit more about the quiz so you can prepare. Good evening, and I will see you in class Monday.